what happens now if it moves off to the left so that they're going to go in opposite directions? So to get the right-hand cart moving towards the left, we need to define this as a negative velocity, because we've been using positive velocities moving towards the right for everything up to now. So if it's going to move towards the left, it's going to have a negative velocity. So we're going to give it a -1. So it's going to move at the same speed as before, but it's just going to move towards the left initially. And we're going to keep the mass of the right-hand one the same for simplicity. So its momentum now is 6 multiplied by -1, which is equal to -6. So its momentum, the total momentum of the system now, instead of being 16 plus 6, it is equal to 16 minus 6. Because the carts are going in the opposite directions, you have to subtract one momentum from the other. So 16 minus 6 is 10, of course. So our total momentum of the system is 10. And if we divide it by the total mass when they stick together, we can find the velocity of both carts. So our masses are 4 plus 6. So we get 10 divided by 10, which is equal to 1. So our total momentum is less than what we had before. Our total velocity is less than what we had before. But note that it's still positive. It's still a positive momentum, which means, which direction is it going to go in? It's going to go in the right, towards the right. So when they join together, we can predict, because it's positive, all these numbers are positive here, so they're always going to go towards the right. Even though the right-hand cart initially is moving towards the left. So let's make sure our numbers are correct. So we've got 4 and 4, and we've got a 6 there, but this needs to be a -1. And then our prediction is going to be 1 for its velocity. Okay. Let's just check that's all correct. 1, 1, 4, 4, 6 minus 1. Looks good. Go. So did you notice that even though the right-hand cart was moving to the left, it didn't have very much momentum despite its mass being greater? And so the cart with the most momentum, which was the left-hand one, won out and pushed the whole system towards the right. So finally, now, could we consider a situation where the momentum of the system is such that after collision, both carts go towards the left? Because in all these situations, we've got positive momentum, which means it's going towards the right. So what about, is there any situation where we could get the carts, when they collided, to go off to the left? What do you think we need to do? Well, what we'd need to do in that case is we'd need to be able to have the momentum of the right-hand cart being greater than the momentum of the left-hand cart in order for them both to move off towards the left after they'd collided. So let's choose some numbers here. We're going to make the left-hand cart momentum a bit smaller, so we're going to go back to an initial velocity of 2 and its mass being 4. So now we've got 4 times 2 equals 8. So we go back to having a momentum of 8 for the left-hand cart. And then for the right-hand cart, we're going to make it have a large momentum towards the left. So we're going to have its initial velocity of -4. Its mass can stay the same, it's quite large, so its momentum now is 6 multiplied by -4, which is -24. So now the total momentum is equal to 8 minus 24, which is equal to -16. So the velocity now can be predicted as -16 total momentum of the system divided by the total mass, which is 4 plus 6, which is 10. So -16 divided by 10 is -1.6. So just make sure that all these are in here. This should be 4